Okay, welcome to objective. Let's put this up here. 3b and 3c. So 3b says I can test a point to determine if it's on the graph of an equation, and we will get to that at the end. You're actually going to try that out yourself. And 3c, I can write the equation of a horizontal or vertical line, and I can graph a horizontal vertical line given the equation. Okay, so a couple of vocabulary words I want to make sure we're nice and clear on is what is the coordinate plane? Okay, well the coordinate plane is the x and y axis intersecting at the origin. So I hear a lot of times people call this, and let me get rid of this here. I hear people call this the graph. This is not the graph. This is the coordinate plane. Okay, so we want to be nice and clear about that. That is a coordinate plane. So what is a coordinate pair or an ordered pair? A pair of numbers defining a point, and they're always written as xy with parentheses around them, and they tell you one of the points on the coordinate plane. Okay. All right, and then what is a graph? Well, we're going to talk about that just a second, what a graph equation is. But let's try these out first. What are some coordinates that satisfy this equation? So I can just kind of guess and check here. So I'm trying to come up with what could I multiply 3 by and what could I multiply 2 by so that together when I add them would equal 12. Well, off the top of my head, I'm coming up with 3 for x and 2 for y. Okay, so now I'm going to test it. I'm going to go 2 times 3 plus 3 times 2 and see if that equals 12. Well, 2 times 3 is 6, 3 times 2 is 6, and that does equal 12. Okay, so this does satisfy the equation. What are some other ones? Well, 0 is a nice number to work with because it always gets rid of something. So if I put in 0 for x right here, if I put in 0, 2 times 0 is just 0, and if you add 0 to anything, it doesn't change it, so that really just gets rid of it. So now I just have 3 times what equals 12? Well, 3 times 4 equals 12. Okay, what's another one? Well, since 0 was pretty easy for me, I'm going to try 0 again, but this time I'm going to try it for the y. So 0 here, 3 times 0 is 0. That'll get rid of that. So now I just have 2 times what equals 12. So 2 times 6 is going to equal 12. All right, I've already come up with 3 points so far, but could I come up with more? Well, off the top of my head, I'm not thinking of any, but there's a strategy I could use. So let me go ahead. What if I were to take this equation and pick another x, okay, any x. I'm going to say 5. Okay, I'm going to take this equation. I'm going to say that x is 5. Well, I can actually plug 5 in, and using my skills of solving equations, I could find out what y needs to be when x is 5. So 2 times 5 is 10. Plus 3y equals 12. I'm going to subtract 10 from both sides, and I get 3y equals 2. And then I'm going to divide, and y equals 2/3. Well, there we go. It's a fraction. So another point that would satisfy the equation is 5 and 2/3. Okay, what are some coordinates that don't satisfy the equation? Well, I could just randomly pick some stuff and then just test it. So how about 1, 7? So 2 times 1 plus 3 times 7. Let's see what happens here. It has to not equal 12. So 2 times 1 is 1. 3 times 7 is 21. And that definitely does not equal 12. So I found 1 point so far. Another thing I could do is I could say, okay, well, if 0, when x is 0, y is 4, that works. Well, then when x is 0, how about if I make y something else? I can make it 5. Since it worked with 4, it's not going to work with 5 because when I go to plug 5 in here, it wouldn't work. Okay, using that same strategy, how about when y is 0, could I use something other than 6? Well, yeah, if I put something other than 6 in there, it's not going to work either. So there we go, 0, 3. All right, so now we're getting to this question here, or not a question, a statement really. The points that satisfy the equation make up the graph of the equation. So let's plot these points. Here's this equation. Here are the points that satisfy the equation. So 3, 2 would be right here. 0, 4 is right here. 6, 0 is going to be a little bit off my graph. I'm just going to kind of eyeball it here and say it's like right about there. And then 5, 2/3 would be 5, 2/3 would be right about there. Well, you can see that they are pretty much making up a line. I had to eyeball these ones here on the end, so not as close on those. This one looks off, and I know why, because it says 5 and 2/3. So 1, 2, 3, 4, 5, and 2/3 is really there. So let me get rid of that one. All right, now I'm going to draw a line and connect these. Okay, there we go. So a couple things I want you to notice about my line. It extends the whole coordinate plane. We're not going to draw these short little lines here. Do the whole plane. And then there are arrows at either end because we're saying it goes on forever. Okay, so all those points that were up here are making up this line. So what about these points that don't satisfy the equation? Well, 1, 7 is somewhere about here. 0, 5 is right here. And 3, 0 is here. So you can see these red points are all not on the line. Well, is it only these points here that are on the line? Well, it should turn out that any point I put in that satisfies the equation should be on the graph. So let me go ahead and find out. So when x is 2, what should y be? So when x is 2, so I'm going to put in a 2 here, what should y be? Well, 2 times 2 is 4. I'm going to subtract 4 from both sides, and I get 3y equals 8. And now I'm going to divide, and I have 8 over 3, and this will be easier for me to graph if I find out what the mixed number is. So 3 goes into 8 2 times, and then I'm left with 2/3. So I have the point 2 and 2 and 2/3 should be on my graph because it satisfied the equation. So 2 and 2 and 2/3, well, there is that point right there, and it is on my graph. All right, so knowing that, let's go back up here, and now let's fill in this definition. The graph of an equation is all the points that satisfy the equation. And something that I would like to note about that is there are an infinite number of points, right? Because there are the points that we found, but there are all the points in between here, all the decimals and fractions and all the parts in between. And then this goes on forever, and this goes on forever. So there's all the negative numbers as well. So there's an infinite number of points. So make sure you pause and get this definition down, and then join me on the back. Okay, what coordinate pairs satisfy this equation? What coordinate pairs do not satisfy this equation? So let's give this a try here. If I have the coordinate pair, let's just pick something random, 1, 3. Is that going to satisfy this equation? Well, I need to plug in my x. Well, there's no place to plug in my x. Okay, well, we're not going to plug in the x then. Let's plug in the y. So for y, I'm going to put in 3. Does 3 equal 5? No, it does not. So it does not satisfy this equation. So here in red, this does not satisfy the equation. Okay, what about 1? Well, if this didn't satisfy the equation, the only place I could put in my 3 was right here. Let me try if I put in 5. Okay, so once again, I have no place to put in my x. I do have some place to put in my y. So I'm going to put in 5. 5. Well, that does satisfy the equation. So then that would make me think that, well, anything with a 5 as the second number is going to work then. So if I have negative 3, 5, well, negative 3, 5, I'm going to plug in a 5 for the y again, and I end up with this equation once again. So negative 3, 5 would satisfy my equation. 0, 5 would satisfy my equation. Negative 1, 5 would satisfy my equation. What would not satisfy my equation? Well, anything that does not have a 5 for the y. So what if I had a 5 for the x? So let's say 5, 1. Well, still, there's no place to put my x. There is a place to put my y, but I would be putting in 1, which does not equal 5. What if I had 3, negative 5? Well, same deal here. Negative 5 does not equal 5. All right, so I have some points that satisfy my equation, and what we learned on the front is those points make the graph of the equation. This isn't a graph, is not a graph. This is a coordinate plane. The graph is the points that satisfy the equation. So negative or 1, 5, negative 3, 5, 0, 5, negative 1, 5. Well, look, they're all lining up there. and they're giving me a horizontal line. Okay, so coming down here, what coordinate pairs satisfy this equation? Well, judging by this up here, being that this is an x, I'm going to try some x's that would match up here. So for instance, what I'm saying is I want to plug in an x that's going to make this equation true. Well, the only thing that's going to make this equation true is a -4. So -4, 3. Okay, no place to put my y in the equation. There is a place to put my x, and -4 does equal -4. So let me set up a couple of points here with -4. And now anything else should be fine. Doesn't matter what my y is. What if I made it 0? What if I made it -4 again? We'll save this one for after when we draw the graph. So let's pull this down here. Okay, so what would be some points that wouldn't work? Well, anything that would not have -4 for the x. Okay, so 3 does not have a -4 for the x. I could put a -4 for the y, but there's still no place for me to plug in my y over here. 3 I can plug in, but 3 definitely does not equal -4. So 1, 4. Again, 1 does not equal -4. Okay, so I think you're getting the point here. So let's go ahead and plot these points in green. So I have -4, 1, 2, 3, 4, 3. And I have -4, 0. And I have -4, 1, 2, 3, 4. Well, this time I am getting a vertical line. So using this vertical line, let's find another point that I could add to my group of points that satisfy the equation. Well, I'd have -4 and anything really. It goes on forever. So -4 and 1,000 would also satisfy this equation. Okay, so I find that this is one of the hardest things for people to keep straight in their head. So I do have a little mnemonic to help you remember them. So you can either remember that y equals 5 is going to go through the y-axis at 5, or all these points that have 5 for y are on the graph. Or another way to remember it is Hoy-Vux. Okay, so right here, draw this line here. We have a horizontal line. This one's Hoy. And then draw this vertical line here, and you notice they're just like the ones above. And this one is Vux. So what does Hoy-Vux mean? Well, first, let's make a quick note off to the side here. Okay, when the equation only has an x or a y, then the graph is a horizontal or vertical line. See, notice these equations, this just had an x. The one above it only had a y, as opposed to this one on the front, which had an x and a y, and that made it a diagonal line. So when it has just an x or y, we're going to use the mnemonic Hoy-Vux. And if you just say that in your head every time you see an equation with just an x or y, or you see a horizontal vertical line, that's going to help you remember how to come up with the equation or graph it. So Hoy has H for horizontal, O is actually a 0, so 0, slope. And we'll talk more about slope coming up, but just for now, just remember Hoy-Vux for horizontal and y. And then y for y equals whatever. So in this case, it's y equals 5 equation. Okay, so remember Hoy-Vux, horizontal, y equals horizontal. And then Vux, of course, would stand for vertical. The slope is undefined, which we will get into a little more later, but it's an undefined slope. And the x is for the equation x equals, and it could be whatever. For this one, we have -4. So x equals -4 equation. Okay, there we go. I have a couple for you to try down here. So to get you started, because it's a little bit different than what you've seen before, given the equation y equals 2x minus 5, are the following coordinate pairs on the graph? Show your work or explain. Well, if they're on the graph, all the points that satisfy the equation, the graph is all the points that satisfy the equation. So it needs to satisfy the equation. If it satisfies the equation, then they're on the graph. So I can take my equation, and everywhere there's a Y or an X, I'm going to put a parentheses because I'm going to plug that in. So here we go. And now my X is 3, so where does my X go? Right here. And my Y is 1. And now I would just need to simplify this equation. If it's a true statement, once it's simplified, then it is on the graph. And so I'm showing my work, and then I would state yes or no. So you go ahead and finish those up. And then down here, graph the following equations and just use what I did on the page above here to figure out what they should look like. All right, thanks for watching.